Hey there, class. Mr. Prusky here. Hope you're having a good day so far. We're continuing with 7.2, day 2. Our central question was, how do we simplify rational exponents using properties of exponents? So we're continuing with day 2. So this is just going to be extra practice on what we covered in day 1. It's just a very hard topic, and so it's just going to be important to go through lots of examples to make sure we really grasp this, because it is very challenging. But just know that it is challenging, and give yourself a break and do your best. Make sure you ask lots of questions and watch all the videos, check your homework against the keys and stuff, and we'll get through this together, okay? All right, so what I'd like you to do too is when we go through each example, see if you can try it on your own first, and then we'll go through it together. So we have number 1 is x to the 1/2 times x to the 1/3. I'll just see if you can give this one a try, and we'll go over it in a sec. Okay, well, it looks like we are multiplying two rational exponents expressions here where they have the same base. So when we multiply with the same base, do we multiply, add, or subtract the exponents? We're going to add the exponents. We're going to do x to the 1/2 times x to the 1/3 is going to be x to the 1/2 plus 1/3. Okay. And in this case, and so if we're adding fractions with different, we need a common denominator for adding fractions. So what's the common denominator between 2 and 3? Well, it's going to be 6. We need to convert 1/2 to 6, which is going to be 3/6. And 1/3 converted to 6. 3 times 2 is 6, so 2 times 1 is also going to what we're going to do there. So we have 3/6 plus 2/6. And what's 3 plus 2 going to be? 3 plus 2 equals 5. So we have x to the 5/6. And also, I'd like you to remember to, if you're able to, write it also as a in radical notation too. So in this case, it's the 6th root, and it's going to be x to the 5th. So both of these are both answers for this problem. All right, let's do number 2. We have the 5th root of x to the 15th divided by x to the 10th. See if you can do this one on your own. All right, so we're taking the 5th root of a fraction, and so one of the properties of radicals is that we can split the radical or the root of a fraction into a fraction of 2 roots. So we're going to split this into the 5th root of x to the 15th, over the 5th root of y to the 10th. Okay? And so what we're going to do now is let's convert this to rational notation. This is going to make things a lot easier. So like if we write it in rational notation, we have x to the 15th, and the root is 5, so it's going to be 15 over 5, right? And on the bottom, we're going to have y to the 10 divided by 5. And then we can just divide this. Well, 15 divided by 5 is x to the 3rd, and 10 divided by 5 is y squared, and there's our answer. Okay? I'd say when you have a lot of like really big radicals and exponents to deal with, I would probably, well, not always, but sometimes it makes sense to go to rational notation first. We could also go back to this. Let's go this. We're going to take this. I want to go a different step here. If we're doing the 5th root of x to the 15th divided by the 5th root of y to the 10th, we can just basically divide right here. We can do 15 divided by 5 is 3, 5 divided by 5 is 1, 10 divided by 5 is 2, 5 divided by 5 is 1, and we're going to get x to the 3rd here as well, over y squared. All right, moving on, number 3, we have 24r s to the 2/3 all over 6r to the 1/4 t to the negative 3rd. All right, give this one a try, see how you do. All right, so we have a lot of things happening here. We have 24 and 6. That's just dividing two numbers. 24 divided by 6 going on there. We have r on top and bottom. We have s to the 2/3 on top, and we have t to the negative 3rd with a negative exponent on the bottom. So we're just going to break this down a little bit, like step by step here. So the first thing we need to know when we have just numbers in front, like this 6 and 24, we're just going to divide them. If they were side by side, we would multiply them. But what's 24 divided by 6? It's 4, right? 24 divided by 6 is 4, and 6 divided by 6 is going to be 1. So it reduces to 4 over 1. All right. Now we have r to to the first power divided by r to the 1/4. Well, if we are dividing r to the first power divided by r to the 1/4, when we divide exponents, what do? Do we add, multiply, or subtract? We're going to subtract. We're going to do 1 minus 1/4. But in this case, we can't subtract 1 minus 1/4. We need a common denominator here. So 1 we could write as 4/4 minus 1/4, which equals r to the 3/4. Okay, so that's going to be r to the 3/4. We'll come back to that in a second. Let's write that down here, actually. We'll do 4 r to the 3/4. Okay, then we have s to the 2/3. There's really nothing to do with that. That one's just going to stick where it is. Okay, and we also have t to the -3rd. What do we do with negative exponents? Well, we flip them vertically. This one's in the denominator, so we're going to move it to the numerator and then change the sign. So we're going to have t to the +3rd. You can put it over 1 if you want to, but there's actually, this is gone. We subtracted, there's actually more r on top than there is on the bottom, so this is gone, and we have a 1 on the bottom here. So our final answer, you can put this over 1 if you wanted to, but really you don't really need it. It's going to be 4 r to the 3/4, s to the 2/3, and t to the 3rd. And there's our final answer. We got rid of all the fractions. We combined all the different bases. We had r on top and bottom. We combined those. S to the 2/3 we didn't really do anything with, and we got rid of the negative exponents. Okay, those are some things you want to look out for to get rid of here. All right, next one. Let's go ahead and change my pen color. Okay, we have 8 square root of x minus 3 square root of x. Okay, so like I was talking about before, I think in the last video, you could write square root of x as just literally like, combine this, like, it's not really 8x, but it's kind of the same thing. If you have, like, for example, 8x minus 3x, what would you get? How many x's would you have? You'd have 5x, right? Well, it's the same thing here, except we don't have just x, we have the square root of x. But that's still kind of like a like term. They're both the square root of x. So these are like terms. We put little circles about them, right? These are like terms. So what is 8 minus 3 going to be? So 8 square root of x minus 3 square root of x is going to be 5 square root of x. Because they are the same exponent. They're both x to the 1/2 power, right? Those are both the same exponent. So I guess that's what we need to look for here. So like terms have same variables, same exponents, and these are both to the 1/2 power. You could also do, like, if you had like 9xy minus, or else do plus 4xy, that would be 13xy, right? Because they both have x to the first power, y to the first power, x to the first power, y to the first power, so we can combine them. They're like terms. So that brings us to number 5. I want you to see if you can do number 5. Give it a try. So like I was just talking about, we have 3gh to the 1/4 minus 11gh to the 1/4. These are both like terms. These are like terms. They're both g to the first power, h to the 1/4. So we can combine them. We can subtract or add the coefficients, the numbers in front. So what's 3 minus 11 going to be? That's going to be -8. So we're going to have -8 gh to the 1/4. And there we go. Now, the next one, if you want to give this one a try, you can, but I feel like it's going to be pretty challenging because we haven't really talked about ones like this yet. So see if you can do this one, but if not, just stick around. We'll go through it together. Okay, for this one, I'm going to go back to an older idea here, okay? If we want to simplify the square root of 20, let's start really basic here, right? If I want to simplify the square root of 20, do you guys remember how we did that? How do we simplify radicals? Well, we need to break down 20 into factors where one of the factors is the perfect and one of the factors is the rest, which is not perfect, right? So what's a perfect square that goes into 20? Hopefully you said 4. So I can break this down into 4 times 5, right? 4 times 5 is 20. And then I can split that in square root of 4 and square root of 5, right? What's the square root of 4 going to be? It's going to be 2. So we get 2 square root of 5. All right, so that's how you simplify radicals. We have the same thing happening here, except now we have a lot more complicated stuff going on, okay? So we are still going to do perfects and non-perfects, but we're going to be doing it with variables too, okay? And the way you tell if variables are perfects or not is if this number, so for example, d to the 4th, if it divides by this number, that's going to be a perfect. If it doesn't, we're going to split it up so that it does divide by that, and keep the rest by itself. So let me explain what that looks like down here, okay? So we're going to simplify. We'll do all three variables here. So we have d to the fourth. Okay? What's the fourth root of d to the fourth? Well, it's saying what times itself is d to the fourth. That's just going to be d, right? That's perfect. That's a perfect fourth, because the fourth root of a something to the fourth power is going to cancel out and give you d. Okay, that one was pretty easy. Now let's do the square root of e. We have square root of e to the 9th. Actually, not square root, fourth root. We're doing the fourth root because we're doing the fourth root in this problem here. The fourth root of e to the 9th, okay? So I want to split this into perfects and non-perfects. So how do I do that? Well, I need to find the biggest number that goes into 9 that also divides by 4. Because basically we're going to split it into everything that divides by 4 and everything that does not, okay? So what can I split up e to the 9th into, where what's the biggest number that goes into 9 that also is divides by 4 nicely? Hopefully you said 8. So I can write this as e to the 8th times e to the 1st, right? And if I do that, let me write it down here actually, because now if I split this up, well, what's the, if we do e to the 8th to the 4th power, I'm going to go to that over here, what's 8 divided by 4 going to be? Well, e divided by 4 is 2, so this one comes out to e squared. Do you see what we did there? So that's how you find perfects with variables. You want to find the biggest number that's divisible by the root, basically, okay? So the way this would simplify would be e squared times the fourth root of e. Okay, let's do f now. We have the fourth root of f to the 14th. Okay, so what's the biggest multiple of 4 that goes into 14? What's the biggest number that divides by 4 that goes into 14? Hopefully you said 12. So we're going to split this into the fourth root of f to the 12th and the fourth root of f squared, right? Because 12 plus 12 times 2, f to the 12th times f to the 2nd is going to be f to the 14th, right? Kind of like we did up here. 8 plus 1 is 9, so 12 plus 2 is still 14. And what does that give us? Well, the 12 divided by 4 is going to be f to the 3rd. And then we have the fourth root. I've got the fourth root here. Fourth root of f squared, okay? So we broke down all the different variables here. So now let's go ahead and do this a little bit differently here. So we're going to write, I'm going to use a different color actually. We're going to do perfects. Oops. Perfects times non-perfects. Perfects times non-perfects. Okay, so what are the perfects that go into perfect fourths, basically? Well, is 12 a perfect fourth, or no? Is 12 on your perfect card? It is not. So we're going to put 12 over here. So we're going to write the fourth root. We're going to keep this over here. So 12 is going to go over here. We broke down d. We said d to the fourth was a perfect fourth. So we're going to go over here. We're going to put d to the fourth is a perfect. So we're going to put it with the perfects because it actually divided to d over here, right? Good. And then we said we split e to the 9th into e to the 8th times e to the 1st. So I'm going to put e to the 8th over here, and I'm going to put e to the 1st over here, okay? We're splitting perfects and non-perfects. And then we had f, the fourth root of f to the 14th. Well, we said that f to the 12th divides into the fourth root really nicely. And then we had 2 f's left over. Those are going to go over here. Okay? So now we simplify this. Well, we know that the fourth root of d to the 4th is d. The fourth root of e to the 8th, 8 divided by 4 is e squared. And the fourth root of f to the 12th, f 12 divided by 4 is 3. So now those are the perfects we pulled out of this entire big expression over here that are perfect fourths. Now the rest of it's just going to stay the way it is. It's just kind of, remember how up here we kept the square root of 5, right? So we're going to do the same thing. We're going to put, we're going to keep the rest of it the way it is. We're going to do 12 e f squared. And this is actually our final answer here. This is like we had 2 and square root of 5, what's left over basically, okay? It's kind of similar to what we did up there. So pretty challenging, but you just want to, basically you want to do the same kind of thing as the square root of 20, where you split it up into perfects and non-perfects, and you basically break up the exponents into what divides by the root nicely and what doesn't, and what's all left over goes in the non-perfect section, okay? So I'm going to zoom out here. We have one more that's similar to what we just did, and that is number 9. So why don't you guys go ahead and see if you can try number 9 on your own, and then we'll go over it in a second. All right, number 9. Let's use green now. So we have the third root of 24, r to the third, s to the fifth, t to the 10th. So again, we need our perfects times non-perfects. Okay, so what are our perfects here? Well, let's figure that out. Are there any perfect thirds that go into 24? There actually is. The perfect thirds that go into 24, I'm going to write them over here. The cube root of 24, I can split that up into a perfect cube that goes into 24 on your perfect card is 8. And 8 goes into 24, so I can write the cube root of 8, and 8 times 3, 8 times 3 is going to be 24, so that's going to be this is our perfect, and this is our non-perfect, okay? So you want to do that for the numbers too if you're able to. All right, then let's go do the r's. What's the cube root of r to the third? Is that a perfect cube? It is, because 3 divides by 3, which is going to be just r, which is nice. And then we have the cube root of t to the 10th. Okay, what's the biggest multiple of 3 that goes into 10? Hopefully you said 9. So we have t to the 9th. Oops, that was too big. And then just t to the first power. It's t to the 10th, right? So this is our perfect. These are our non-perfects, right? I think we got everything now here. So now let's split this up. So we're going to put our perfects over here. So we're going to do the cube root. Keep the cube root where it is for now. Cube root of, so we split up our perfect cube root of 24 into cube root of 8. Then we had r, and then we had t to the 9th. Times, and then we had the cube root over here. What the non-perfects were, we had cube root of 3. We also had t to the first. Oh, we forgot to do the s's. I forgot the s's. Whoops. Sorry, we're going to go back a little bit here. So we'll keep the t. We're going to erase that. Sorry, guys, I goofed up here. You probably won't be able to see what I wrote because I kind of goofed up. We also have to do the s's. So let's do the cube root of s. Cube root of s to the 5th. What's the biggest number that goes into 5 that also divides by 3? Hopefully you said 3. So we have s to the 3rd. And then 3 plus 2 is 5, so we need s squared over here. So this is our perfect, and this is our non-perfect. So we also need, under our perfects here, we need s to the 3rd. We need t to the 9th. And then in the non-perfects, I'm not sure how this is going to record. Hopefully it can make sense by the time I'm done writing it here. Our non-perfects are going to be 3, t to the 1st. Actually, we're going to not do t to the 1st. We're going to do s first. We have s squared, and then we have t to the 1st. Okay? And now we need to take the cube roots of all the perfects, which is going to be, cube root of 8 is 2. Cube root of, I forgot, this is r to the 3rd right here. Yep, r to the 3rd. Huh, okay. Yep, okay, we're good. So the cube root of r to the 3rd is r. The cube root of s to the 3rd is s. And the cube root of t to the 9th is t to the 3rd. And then we do times the cube root of whatever's left over, which does not have perfects that go into it. So we have 3s squared t. And this is going to be our final answer. All right, I hope that recorded nicely. But if not, take a look at it now. And make sure you check the completed notes too. Because there are completed notes that'll go through this here, but the video is unclear. But yeah, there we go. All right, we have 2 more examples here. So we have the 5th root of g squared over h to the 7th. Why don't you go ahead and see if you can complete this? Go ahead and do that. All right. So this one, again, we have a root of a fraction. So we're going to split up into a fraction of 2 roots. So I'm going to write the 5th root of, actually, you know what? I'm not going to go with roots this time. What I'm going to do is I'm going to write it in rational exponent form. So I'm going to write it as 2/5 on top and h to the 7/5 on the bottom. Okay? All right, now this is a little tricky because what we need to do is we need to rationalize the denominator. We cannot have any roots in the denominator for these kind of problems. So I believe I talked about it in the last video, but the way we do that is we need to multiply top and bottom by h to the something that will make it a nice exponent without any roots on the bottom here, okay? And the way we do that is we need to multiply by a rational exponent that's going to complete this and make it complete the 7/5 and make it divisible by the root, which is 5, okay? Because if you recall, so if I do h to the 7/5 times h to the, I'm just going to make something up here, the 1/5, well, I'm going to add the exponents, I'm going to get h to the 8/5, right? Okay, so it's a similar thing here, but this doesn't help us. The 8/5 doesn't help us. What does help us is if we could get the end result to be something like h to the 15 over 5, because we can reduce that to h to the third, right? We can reduce that to h to the third. And so what could we multiply by? What exponent could we add to make something? What's the next number that above 7 that's divisible by 5? Hopefully you said 10, right? So if we multiply the bottom and top by 3 to get to 10, that's going to fix our problem, okay? That's going to fix our problem because 7 plus 3 is going to be 10. Let's go ahead and simplify this now. So we're going to have g to the 2/5 times, we'll just put h to the 3/5 over, and now we have h to the 7 plus 3 is going to be 10/5. Now how does that help us? Well, it's 10 divided by 5. That is a nice answer for us. That's going to be g to the 2/5, h to the 3/5, and then it's 10 divided by 5 is going to be h squared, which is excellent. That's what we want. We do not want any radicals, and the h squared is not a radical. Another thing you can kind of look out for here is that these are both to the 5th root. So we can actually combine this into one root here, 5th root of g squared h to the 3rd, all divided by h squared. And that's going to be our final answer. If you kept it like this, that would be fine as well. But if you have the same root being multiplied together here, you can combine them under one root. All right, one last example. Here we go, number 8. See if you can give this one a try. All right, we have x to the 1/4 divided by x to the 1/5. So looks like we're dividing by numbers with the same base. So when we divide, what operation do we do in our brains? We subtract. We're going to do 1/4 minus 1/5. And the least common denominator between 4 and 5 is 20. So if I make multiply to get a common denominator here, I'm going to have 5 over 20 minus 4 over 20. And what's 5 minus 4? 5 minus 4 is going to be 1 over 20. So we get x to the 1/20th. Or, this one I can write as a root, the 20th root of x. And these would be both final answers right here, okay? All right, we covered a lot there. It's a hard lesson. Make sure you're asking lots of questions, getting help during your homework. Thank you for watching, and have a great day.